Go.
Okay. So it's saying the function h is defined by h parenthesis x parenthesis equals x squared plus 7. And then it says find h parenthesis 5z parenthesis. And that's it.
Well, what are we going to do with what's inside the parentheses?
I have to plug that in for x.
Okay. So what do we have?
So it would be 5z squared plus 7.
Again, very important that you use the parentheses, because otherwise you get the wrong answer. In other words,
Oh, gotcha.
this is 25z squared plus 7.
Gotcha.
And if I accidentally didn't put the parentheses there, I might be inclined to say it was 5z squared, and it isn't.
Okay.
Okay. What else?
I got the next one. So the next one would be this one. I'm definitely going to send you.
Okay. That last one, incidentally, was imaginary solutions only, which I thought was going to be a problem of. In other words, if they ask you to find the zeros, there aren't any real zeros of that last problem.
Oh.
In other words, when you solve it, x squared equal minus 7, that's only imaginary.
Okay, I just sent it.
Yeah. Let's see. Let me have a look at it before. We can probably work on just this.
Okay.
Okay, what does this mean?
So it's saying find f of 1.
Yeah, what is f of 1? This
So
is,
that would
first of
be
all,
1 on the x-axis.
Right. In other words, the vertical axis is f of x, the horizontal axis is x. So f of 1 means what?
Pretty much like where the graph touches on the 1 on the x-axis.
Okay, so what's the answer?
It looks like it touches at like 2 and -2.
No. First of all, it's the x coordinate's got to be 1.
Okay.
So it's got to be right there.
Gotcha.
And it's not where it touches
So
the
-4.
axis. That's 1. In other words, it's what is f of x? What is the graph when x is 1? And if
So
we label
-4.
that, yeah, about -4 from what I can see. Okay. And this is your computerized, you have to answer it in the computer.
Unfortunately, I really do not like the program.
Okay. Now, the second part of that question is, give me one value of x where f of x is -1.
That would be -2 or 2, either or.
Yeah, either one. It's hard to tell. But yeah, there's one value right there that looks like 2. And then there's another value right there which looks a little bit less than -2. But either one of those, I would go with 2. Just mean, I kind of hate these questions. They assume that you have to have integer values almost, which are awfully hard to assume when you're reading a graph. So, okay, is that it on this one?
Yep, that's it for this one.
Okay.
I'm going to send you the next one.
Okay. You still getting rain in Florida? My son said it.
Yep, there are lots of thunderstorms today, actually.
Yeah, I guess you're getting a little bit of that hurricane that hit the Gulf Coast.
Yep, we're talking about there's more weather to come.
Yeah.
I just sent it to you.
Okay. Yeah, I just got it. Huh. My phone didn't go off. Usually it tells me. Now this one I can download. Did you send these differently?
I sent this one through Gmail. The last one I sent through Apple Mail.
Okay.
Does it come out better through Gmail?
This one comes out in a file that normally I can expand. Unfortunately, that feature stopped working. I don't know why, but this should be good enough. Can you see that? Yeah, okay.
Yes, I can.
I don't think I have to expand it then. The entire graph of function g is shown in the figure below. Write the domain and range of g using interval notation. Okay, so the domain, get your eyes looking left to right. What's the domain go from? And tell me whether it's parentheses or brackets.
Okay, so it would be a parenthesis since it's not a full circle from -3 to 3, where it'll be followed by a bracket. And then the range will be bracket -2 and parenthesis 5.
Okay.
And
anything else?
that's it for that one.
That's all there is there?
Yep.
Okay.
So the next one is, 1 second. The next one is g of x.
Hold on a second. I'll just write on my semi-whiteboard here.
Okay.
G of x
equals square root of 20 minus 4x. And then it says find the domain of the function.
Okay. So, when you're thinking about domain, you kind of want to think about what can x not be, not so much what can x be, because usually x can be almost all real numbers, but not in this case. So how do I solve for the domain?
Would I put 0 in for x or no?
No? What's the restricting factor on the domain here? It's this radical sign, right?
Okay.
So what does that radical sign mean? What can you take square roots of? And what can you not take
perfect squares?
Huh?
Non-negative numbers.
Okay. So what do I have to do to 20 minus 4x? What does that have to be equal to or greater than?
0 or greater than 0.
There you go. That's how you solve all of these problems involving a square root. Okay.
Gotcha.
And so now solve that.
Okay, so plus 4x, and divide both sides by 4, and then it'll be x equals 5, or not equals, it'll be x is less than or equal to 5. And then it says write it in interval notation.
Okay, so what is that?
So I would do bracket.
No. Remember, you're always starting from the left on the number.
Okay.
As far left as you can go on the number line. What is that?
So parentheses 0.
Negative infinity.
Okay, negative infinity because it can't
Notice
be
that x can be a negative number. X could be minus 10. Then I'd be taking the square root of 60. So there's nothing wrong with negative x's. And that's what that means. Okay? If I want to turn this around and display it like I'm more used to, just switch the sides and switch the sign. Now, this doesn't confuse anybody. That, you know, that number less than 5. For some reason, just because we're not used to seeing inequalities with the variable on the right side, this is more confusing. So you can always just switch sides as long as you turn, you don't have to switch signs, just turn the direction of the inequality around and put the variable on the left side. So what's the rest of this answer? Negative infinity?
So, and then there will be, what's the name? Comma 5 bracket. Okay, I'll pull up the next one. Okay, so this is the next one. So it says we're going to have to define the functions f and g, and f of x equals x minus 3 divided by x squared minus 9.
Okay.
And then g of x equals x over x squared plus 16. And then it says find the domain and interval notation of both.
Okay, that's it? Just find the domain?
Yep, of both.
What's the restriction on f of x? Remember, when you think about domain, always be thinking, what can x not be?
Well, it can't be anything less than 3, I see from up top.
How about minus 1? Can it be minus 1?
No. It would be a negative.
What would be negative? You don't care if it's negative.
Oh, okay, because I was thinking minus 1.
What's the restriction? It's not the same as a radical sign. This has division going on. Whenever you have division going on, what is the restriction?
It has to be a positive? Or...
You can divide by a negative number. There's only one number on the number line you cannot divide by. 0.
Okay.
My denominator,
so it'd be undefined.
My denominator cannot be 0. So if I solve this little problem, I get x cannot be plus or minus 3. Those are the only two values for x that make that denominator 0.
Okay.
So what is the domain on f of x?
So it will be negative infinity with the parenthesis to negative 3 parenthesis. Then it will have a u. And then it will be parenthesis 3 to infinity bracket.
Hold on. What can x not be only?
-3 and 3.
Okay. So if I write 3 there, you're excluding all the numbers between 3 and
In
minus.
between. So it'd be -3 and then comma 3. Then parenthesis. And then it'll be 3, or yeah, u, parenthesis 3, comma, infinity, bracket.
Parentheses. Always
That
parentheses.
would be parenthesis.
Infinity signs. Never, ever a bracket.
Okay.
Okay? And this covers every number on the number line. That's basically all real numbers except +3 or minus.
Uncle Buddy's leaving.
Give me 1 second, Mr. Cowan.
Sure.
I'll be right back. 1 second.
Caleb's going to tell you about the Do you want to go from?
I'm back. My uncle was just telling me bye since he's going to the airport back to Chicago.
Okay. Now, before we leave f of x, let's just do one thing here.
Okay.
If I factor the bottom, that's difference of perfect squares. And then you can cancel that with that. And so what this function really is this. And it appears to change the domain. In other words, this domain is only no -3s. But what it happens when you cancel a linear factor out like this is you leave a hole. And the hole comes at x = 3. So it doesn't change your domain at all. In other words, the domain is not the domain of this function. The domain is the domain of that function. And just because you've canceled a factor out does not change the original domain restrictions, which is x can never be +3 or -3.
Okay.
Okay? Even if you've canceled out one of the factors, doesn't change anything. Just changes it, instead of a vertical asymptote, you'd have a hole. Okay?
Gotcha.
Let's look at g of x. So tell me what the first thing I should write is. Trying to find the domain.
Well, I don't know the first thing to write, but I'm pretty sure it's all real numbers.
Correct. In other words, the only way it wouldn't be all real numbers is if x² + 16 was equal to 0, and it can't be. That's a positive number. That's a positive number. You can't add two positive numbers together and get 0. So there is no denominator, or there's no way to make the denominator 0.
Okay. Since it's a positive.
Right. Sometimes whenever you have an expression like this, some number, as long as c is positive, that whole thing is positive, because that is always positive, x². There's no way that's ever negative. It can be 0, but as long as this is a number greater than 0, like 1 or any other number, then x² + 1 is always a positive number. And a lot of times it's nice to be able to see that. And that last problem was an example.
Okay. I just emailed you the next photo.
I don't know. I can see it. Can you see it?
Yes, I can.
Okay. And you probably also can see it on your end, maybe, or not?
Yeah, I can see it on my end too.
Okay, good. So as long as I can see it, we know you can see it. Okay.
Yep.
Okay. Write the expression g dot h of x, g
It's
plus
multiplying.
of x, and g minus h of -3. Okay, so you correctly said that was multiplying. So what do you get? Here, let's do it this way. This is probably the easiest way, is to leave the monomial term on the left. Now you just have to distribute it. You don't have to do any kind of every term by every term. Actually, it is every term by every term, but so what's the answer?
4x cubed plus 4x squared.
Okay. And g plus h.
4x squared plus x plus 1.
And g minus h evaluated at -3. First of all, what's g minus h?
That would be x plus 1 minus 4x squared. And now the -3 has to be substituted in for the x's.
Okay. Now, just
So it'd be
go ahead.
-3 plus 1 minus 4 times the parentheses of -3 squared.
All right. You can figure out what that is. Well, tell me what h.
Yep, so that would be.
Go ahead. That's negative.
Okay, so it would be 9 times -4, which would be -36, and it would be -2 on the other side. So it would be -38.
Okay. Now tell me what h minus g would be.
H minus g would be 4x squared minus x plus 1.
No. That's why I asked.
Oh, it would be x, or minus x minus 1.
Mm-hmm.
Oh, since it would be like I distribute a negative in there.
Exactly. In other words, what it really is 4x squared minus the function. And the function is x plus 1. And now,
Okay.
because of those parentheses, it becomes 4x squared minus x minus 1.
Gotcha. So I have to look out for that.
Yes.
Okay. Now I'll pull up the next one.
Okay. This one you're going to send me, or you can?
Yep, I'll send it you this one as well.
Okay. We're having a heat wave here in Colorado. It's 95 degrees out.
Holy cow, that's hot over there.
And unfortunately, I don't have air conditioning because we don't have that many hot spells here. You almost don't need it here. But
Oh, okay.
hot in my office right now, especially since I'm on the upper level of my house.
Yep, the heat will rise.
Yeah, it's hot in the evening. I tell you what. I got a portable air conditioning in my bedroom, but I don't have it in here in my office. Let's see. Now, if I open this with paint, I can zoom in, but I guess I don't need to. This is good enough. Okay. Doesn't look like we need the domains of the original functions.
Nope.
At least I don't think so. The thing is that when you create composite functions, frequently the domain changes a little bit. I don't think it's going to here. What is that equal to?
That one is f times g.
So,
You're asking?
yeah, what's the answer?
F times g. It would be like 1 over 5x squared plus 3 and square root of x plus 2.
Make sure your parentheses.
Okay, parentheses square root of x
Because
plus
again, it matters. Okay. Now,
okay.
that can never be 0 by the same reasoning. We have an x squared plus 3. So the only thing that we're concerned with is the other half.
The square root.
So what should I write in terms of an inequality that I can then solve?
Okay, so I'm trying to think of what we would put, since I know that the
Always
left
work
side's
with
fine.
inside the radical sign. The radical sign is the restricting factor here. It's actually two restricting factors. The radical sign is 1, but it's
like
also a
-2.
denominator. So it can't be 0. Normally you can take the square root of 0, but you can't if you're dividing by it.
So inside the radical x couldn't be -2.
X, here's what you do. You just always start inside the radical, whatever it is. Normally, I would say it has to be greater than or equal to 0, but in this case, it has to be greater than 0. It can't be 0, because then we'd be dividing by 0. And that's almost always the only two restrictions you ever have on these domain problems. Is you can't take the square root of negative numbers, and you can't divide by 0. Just those are the two that if you always remember those two, you won't have any problems. So, what's the answer here?
So for this one, it would be x is greater than -2.
And interval notation?
So for this, it'll be -infinity.
X is greater than -2.
Oh, okay, so it'd be parentheses -2 to positive infinity.
Okay. And that's it. And it turns out that that's a restriction on that same function right there, g of x, same domain. And this one's all real numbers. So when we combine them together, sometimes you create a different domain. But with composite functions, the domain is whatever is the most restrictive domain. Okay? Just always remember that. In other words, you want to take your domain of each function, and then you want to take the domain of it's not really a composite function, that's the product of two functions. Okay?
Okay.
So, f plus g, here, let's
1 over 5x squared plus 3, and then plus 1 over square root of x plus 2.
How am I going to add those two functions?
We would have to get like denominators.
Okay. What's that common denominator going to be?
It would be, so I'd have to multiply by 5x squared plus 3 on the right side and square root of x plus 2 on the left side.
I don't know if you don't mind if I change it.
Nope, no problem.
Just because I already started writing. Besides that, I like to keep everything in order. In other words, I started out with everything on the left. Let's leave it there.
Okay.
You know what I mean?
Yes.
Keeps you from making mistakes. Now, I'm going to have a numerator, right? In fact, this numerator has to be x plus 2. And this numerator has to be 5x
squared plus 3.
plus 3, those numerators aren't going to be, they're not going to matter. Okay? I mean, this numerator would normally matter. That would tell me that x has to be greater than or equal to negative 2.
Mm-hmm.
This one's going to tell me the same thing, only going to be more restrictive. We just looked at that one. What's the domain on that?
So it'll be the same thing. It'll be
Yeah.
2 and infinity.
Exactly. Negative
And it
2.
doesn't matter what's in the numerator.
Not really. Not in this case. Not even if it cancels out like this. Because in other words, notice that there is a restriction from the numerator, but it says x has to be merely greater than or equal to minus 2. So this is a little more restrictive, and that wins in the domain contest. And the more restrictive you are, that's the domain.
Okay.
This certainly doesn't really matter. That's always positive again. That's always positive again. So the only restriction here is this right here. You can't divide by 0. You can't take the square root of a negative number.
Okay.
Now,
Got it.
was there anything else on this page? I don't think so. No. Yeah, they didn't even ask you. Now, I don't know. I don't want to confuse you, but you can have a different domain when you combine functions. I don't know that you can necessarily, yeah, you can certainly have it if you divide. You could create a different domain. In other words, here, if I said f of x was x, and I said g of x is x plus 1, well, the domain on both of those functions is all real numbers. But if I said g of x divided by f of x, well, now I have x plus 1 over x, and now x can't be 0. So by dividing two functions whose domain was all real numbers, you've turned it into a function that has a more restrictive domain. Now x can't be 0.
Gotcha.
Okay. So these questions they're asking you here, they're not even asking about the original functions. They're only asking about that function and that function.
Okay.
Then I don't know what you call these. They're not. I don't think these are called composite functions. Composite functions are f of g or g of f, fog or goff. Those are composite functions. And same thing with those. It can affect the domains drastically by turning it into a composite function.
Yeah, that makes sense.
Okay, what else you got?
Okay, I'm emailing you the next one. Talking about even, odds, and neither. Just like before.
Four functions are given below. Okay. Either the function is defined or the entire graph is shown. For each, decide whether it's even, or odd, or neither. What makes a function even?
That they have to be symmetrical.
Well, if you're looking at the graph, yes. But down here, you're not looking at the graph. So there's
Okay,
got
so
to
they have to be squared.
There's got to be more than one way to determine whether a function is even. It's not just symmetrical about the y-axis. I mean, that is the case. In other words, by looking at this, you can tell that is symmetrical about the y-axis, and that does make it what? Even or odd?
Even.
Okay. And this one is what?
Would that be neither?
Correct. What does it have to be odd?
Symmetrical on the x-axis,
No, the origin.
the origin.
Yeah.
Okay.
In other words, if this looked like this, instead of the way it looks, it would be symmetrical about the origin, and that would be odd. Symmetry
Okay.
about the origin means can you reflect it over the x-axis and the y-axis? And if you take
Okay.
this right here, if I reflect this top half right there over the y-axis and then over the x-axis, I get that. So that's
Gotcha.
symmetry about the origin. Unfortunately, what we're looking at here has been moved 2 units or 1 unit to the right, so it's no longer symmetric about the origin. So it's neither. Now, when we just have the function, you got 2 choices. You can graph it and see if it's symmetrical, but there's a better way to do it. There's an algebraic way to do it.
I just think of it if it's even, and if it's even, number like 2, it's even, and then if it's odd, it's
Here's the
odd.
definition. Always try minus x. No matter what the function is, figure out what the function evaluated at minus x is.
Okay.
Well, that's equal to 3x squared, which is equal to g of x. And even functions are where g of minus x is equal to g of x. That's what makes a function even. Since it's exactly the same thing, g of minus x equals g of x, or 3x squared, which is g of x, then that is even.
Okay.
Okay? So what are we going to have to do with this fourth one? We've got to evaluate what?
Negative x.
Okay, so we want to know what h of negative x is. So tell me what to write.
Okay, so it would be negative 4 parentheses negative x to the 5th. Plus 7 parentheses negative x to the 3rd.
Okay, now simplify that.
Okay, so it would be negative 4 times negative x plus
Hold on.
7.
Hold on.
Okay.
It's not 4 times negative x. The negative x is being taken to the 5th power. So do that part first.
Okay, so that would be, it would remain as a negative.
So it'd be negative x to the 5th, right?
Correct.
Times negative 4 is
Which
positive.
would make it a positive.
4x to the 5th. Over here, that becomes
Over
negative
10,
x
that's
cubed.
negative
So it would become minus
7x.
cubed. Well, it's certainly not even. In other words, h of minus x is not equal to h of x. But it is equal to negative h of x. That makes it odd. In other words, if h of negative x equals negative h of x, that is odd. That is the definition. It has to be that. Well, notice that I can take a negative, I can factor a negative sign out of there, and I get minus 4x to the 5th plus 7x cubed. And that's what I started with.
Okay.
In other words, h of negative x equals negative h of x. This is odd.
Okay.
And that's always the best way to tell.
To make
Well,
sure.
I don't know. I mean, it's pretty evident when you see a graph. You can tell instantly whether it has symmetry about the y-axis or symmetry about the origin. But if you don't have a graph, in other words, I know what that graph looks like. That's a parabola. In other words, that looks like that. Okay? But this one's not so easy to know what that looks like. Without a calculator to put it in, I'd much prefer to do that algebraically. But it's a little tricky. You're either looking for h of negative x to be either h of x or negative h of x. So that's what you're looking for. If you can't turn it into either one of those, then it's neither.
Okay.
Always. You have to be able to turn it into either h of x or negative h of x.
Gotcha. So I'll verbalize this next one.
Okay.
So it's saying graph the function f of x equals 3 square root of x minus 4.
I think the easiest way to graph these is always treat them as a transformation.
So I'd move to the right.
What's the parent?
4.
What's the parent function? Start there always. If you're going to treat something as a transformation, make sure you know what the parent function is.
Okay, so square root of x.
So what things are being done? And let's go ahead and graph the square root of x. Not only do you need to know the parent function, but you kind of need to know what your 10 basic elementary parent functions look like. Okay? Notice that the domain of square root of x is 0 or better, or 0 or higher, and the range is also 0 to infinity.
Mm-hmm.
So what things are being done to that function right there? What's the consequence?
Have to move to the right.
Okay, let's start with what's inside the radical. Yeah, what's the 4 do? Moves it to the right?
Yes. 4 spaces or points.
And it does not change the shape. I don't know whether there's a mathematical term for that. I would say those two curves are parallel. Although that is not a term I've ever heard used in math to compare two curved lines. But you know what I mean, I think.
Mm-hmm.
Okay, and what's the 3 do?
It expands it on the horizontal axis.
Not horizontal. The 3 is
Vertical.
not inside the function. It would have to be inside.
Okay.
In other words, the square root of 3x would be a horizontal stretching or shrinking. But when the 3 is outside your basic function,
it's a stretch.
It's a stretch. In other words, what we're looking at, if I called that g of x, then we're looking at 3 times g of x outside the function. So it's a vertical stretch, and what are the consequences? What's the blue line going to turn into?
It's going to be more upwards.
Yeah, it's a vertical stretch. So, and the best way I think to think about these things is that point right there has to be 3 times higher. So really, it has to go through that dot. And if you really want to draw these somewhat accurately, that's what you want to do. Take that point there, make it 3 times higher. Take that point there, make it 3 times higher, and now connect the dots, and you end up with that.
Okay.
Okay? All right. Next one going to be verbalized, or what's that?
The next one, pretty much for this one, it says graph the following function. 3 over the square root of x minus 5. Or it's how can I explain it? The cube root. Yeah, cube root x minus 5 I meant.
Okay, like that?
Just get rid of the 3 over top. I messed up.
Oh, so it's 1 over the cube root?
No, it's just cube root of x minus 5. Yeah, I ended up messing up trying to think of what it was.
All right. What's the question? The domain?
It's just asking me to graph it.
Oh,
So it's saying plot 1 point
okay.
that makes the cube root of x minus 5 equals 0, and then plot 2 points to the left and 2 points to the right.
It's the parent function here.
The parent function will be square root of x.
Cube root of x.
Oh, cube root of x.
Hmm?
Yeah, I remember that now.
Now, cube root of x, first of all, y
Because
equals x cubed looks like this. So the cube root of x is the inverse. So, I'm never very good at drawing these, but I believe, hold on a second, let's see. The way I would draw this, because I know it's the inverse, would be to reflect it over that line. And if I reflect it over that line, it ends up being like that. Okay? So that is y equal x to the 1/3. Cube root of x. Now,
Okay.
what's the transformation doing?
So it'll be moving me to the right 5.
Okay, and the only point we really know is that one right there. We know that goes through the origin on my parent function. So that's the point I'm going to move to the right. And then I'm going to try to graph that exactly the same. I'll give it my best shot, but I'm not much of an artist. That's supposed to be parallel to the blue line, just moved over. No difference in shape.
True.
And notice the domain is all real numbers. You can take cube roots of negative numbers. You can't take square root. You can't take even roots. Odd roots, you can always do it. This is also all real numbers for a domain.
Okay.
But if I made it this, now it's only greater than 0.
Gotcha. That makes sense.
Okay?
I'll pull up the next one. Okay. I guess this one. Actually, no. This one I don't need to send to you. Yeah, this one's fairly easy, so I don't need to even go over this one.
Okay.
It's just asking me about like what transform or translating these functions.
Okay. Most important thing on that is all horizontal translations are inside the function, all vertical translations are outside the function.
Okay.
Key thing to remember, including reflection.
Including reflection. So all outside are vertical and all inside are horizontal.
Yeah. In other words, if I have this, and I said, well, what is this? Excuse me. G of x is negative x squared. That negative is outside. That is negative g of x.
Okay.
And the
So
negative sign is outside the function, so it's a vertical reflection, which means a reflection over the x-axis. In other words, it would be like that instead of the other facing.
Wait, so say that every time if it's outside, it's over the x, and if it's inside, it's over the y?
Yes. If I said, well, what do I have here? If I substitute, if I put the negative sign inside the function like that,
yes,
then that negative sign is a reflection over the y-axis. And you can see why. Because when I multiply that out, I get the same function. It's x squared. when I expand that. In other words, that is an even function. It's symmetrical about the y-axis. And when it's symmetrical about the y-axis, you can substitute a negative x and get the same function.
Okay. So then I'll pull up the next one.
We've got about 10 minutes.
Okay, that's fine.
Prioritize or anything?
Yep, I'm prioritizing right now. So the next one I have is graph the equation y equals 4, absolute value of x minus 5, and then plus 4. So I know the parent function is the absolute value of x, which looks like a v.
Take them one at a
And
time.
then,
Take the easy ones first.
okay, so I have to
I
move.
mean, take the transformations that don't change the shape first.
Okay, so right now I know that I'm going to be stretched vertically by 4.
That changes the shape.
Oh, okay, never mind. Moving me then.
I would save that for last. Yeah. In other words, that one doesn't change the shape, and that one doesn't change the shape.
Okay, so I move to the right 5 on the x-axis, and I move up 4 on the y.
Okay. So to the right 5, up 4. There's my new vertex. Same exact angles. So that's this part of it.
Correct.
Now, what does that 4 do?
Multiplies it by 4, pretty much. So I have to stretch it out by 4 vertically.
Okay. And what that
And
basically means
distance.
is make it steeper. Because every one of these points has to be 4 times away from the x-axis is that point. And I didn't even make it nearly steep enough. But you get the picture. A vertical stretch factor makes these things steeper.
Yep, I got the picture.
Okay.
Okay, I got another one. So this question's asking, actually no, this is just asking me to translate it. That one's easy. I'll pull up another one. Okay, now I have it.
Okay.
I'll send you a picture of this one since it'll be a little bit.
There are some problems that are transformation problems that are a lot harder than they look. If I don't know if they're ever going to give you one. In other words, if I said to you this, what's the transformation?
I don't know.
Okay, what you have to do there is factor out that negative sign and make it look like this. And now that negative sign is outside the function. Excuse me, it's inside the function. So that is a horizontal reflection. That is a horizontal shift 3 units to the right.
Okay.
Okay. For it to be a vertical reflection, the negative sign would have to be in front of the e, being outside the function. When it's in front of the exponent, it's
horizontal.
It's inside the function. Now, I don't know if they'll ever give you anything that hard that requires
Nope, never
to
seen
factor
it.
out that negative sign. But they might. As a tough question. I don't know. What do you got?
Seems like it. I think I emailed it to you.
Okay. There we go. The classic calculus, the difference quotient. Remember this?
A little bit. I have an idea how to do it. It would be 2x squared plus 8 plus h.
Let me give you a little bit better way of starting this.
Okay.
Figure out what this is for starters. Just spell it out.
Okay, so that would just be 2x squared plus 8 plus h.
Well, no, when I say spell it out, I mean do this.
Oh,
That's
okay.
what it is. Now you do have to expand it, but not yet. In other words, we now have that, right? Well,
Yes.
we know what that is, so let's just
Pretty much
write
the
it out.
negative.
So, yeah, so we'll make it 2 times x plus h squared plus 8 minus f of x. And again, here parentheses are incredibly important
Okay.
because otherwise you'll miss the sign on that 8. Okay, and now I'm dividing the whole thing by h. So, what's the next thing I can do?
We can cross out the h's.
Well, not
Cancel the h's.
yet. Not yet. You got to expand that. In other words, the first thing you want to do to simplify an expression, get rid of all the parentheses. Well, the only way to get rid of the parentheses is to square that. What do you get when you square
it? X squared plus h squared.
No. Most common mistake in algebra is what you just did. You have to foil it.
Oh, I foil it. X plus h. Yep, I see.
Okay, so it's this. Still, now I'm going to get rid of the parentheses on the right, making that a negative 8. Still all over h. And every time you do a difference quotient in calculus, what ends up happening is the numerator, anything that doesn't have an h in it, goes away. Notice that that 2x squared cancels out with that 2x squared.
Mm-hmm.
I had a plus 8 here also. That plus 8 cancels out with that minus 8. So everything I'm left with only has h's in it. So here's what I got up here in the upper left. 4xh plus 2h squared. Everything else is gone. All divided by h. And now notice that the h's cancel.
Correct.
So this is going to simplify to 4x plus
2h.
h. And that's the answer. Now, typically they say, well, what is that thing? What's the limit of that as h goes to 0, which would be 4x. But they don't actually say that here. They say just simplify it as much as possible. So this is the answer. This is not a limit question. It just says find the difference quotient.
Okay.
Were you able to put that in? Did they accept it?
Yeah, it said it was correct.
Okay. Yeah. These computer, where you have to answer it by a computer, they can be tricky.
Yeah, they're really specific.
They are.
Otherwise,
Well,
the
you gotta
teacher
put
could
it
say yes or
exactly
no.
as they want it. Yeah. All right, Taylor.
Alrighty, thank you for the help. I'll see you soon.
Well, good luck on your
Thank
test.
you. Have a good night.
You too.
Thank you.